My name's Tyler. I'm one of the organizers for KernelCon, and hello. I have the pleasure of introducing this session's speaker. I worked with him a while ago at a consulting pen testing place, and I learned back then that he was a very good hacker. And if you have any doubts, last week, I can share a story. Last week, we got an email from Sam saying just all it contained was a link to a former KernelCon subdomain for a CTF thing. And when you clicked it, it said like pwned by Sam. And so there's more evidence that Sam is a great hacker. And so thank you for pointing out our configuration problems. But without further ado, here is Sam Curry doing web hackers versus the auto industry.
Hello, hello. I should do an introduction for Tyler. He's a very, very, very good hacker. I don't know. It should be opposite, to be honest. But yeah, thank you guys for coming. This is web hackers versus the auto industry. And I'm presenting this talk, but it's a talk that a lot of work was contributed by different people. So huge thanks to Nico Rivera, Brett Bierhaus, Mike Robert, Ian Carroll, Justin Reinhardt, and Shabam Shah. They basically, I think maybe like 8 or 9 months ago, I started spamming them in Discord, like trying to get them to hack stuff with me. And then we put together like a little group chat. So we all kind of worked on this over time, and like it eventually became, let's hack all the car companies and see what we can do. So we put it into this talk, and it's just a bunch of work. But yeah, I'll go ahead and kick things off, and really quick intro. It doesn't matter too much, but basically just bug bounty hunter, like hacking stuff. I run a blog where this was like actually kind of blogged about. But luckily for us, like a lot of more disclosure was approved in between the blog post and now. So there's actually a few more bugs here that are kind of cool. So to give a little context, a long time ago, I think like the fall of last year, I did a road trip with a couple buddies down to Washington, D.C., and we're on a college campus. And we're in the bottom left of the college campus, and we got to get up here to the dorms or whatever. And we're trying to find a way to do it, and we don't have a car, so we're like, all right, college campuses, easy. We got VO scooters. So we find these scooters, and there's an app you can download. And being the 2 a.m. like escapades we're on right now, we decided to take the scooters to a dorm room. And when we go to the dorm room, we start intercepting the app traffic just to kind of play around with them. And we realized that the app traffic for the scooters is like kind of interesting because you can just like find all the scooters and they have these like numeric IDs, right? So I think it's like University of Washington, D.C., and it's like 3 in the morning. And we realized that you can actually honk or flash in each of these scooters, right? And it's passed in this really big JSON array, right? And we have a scooter in our dorm room, and we crack the window open, and we're like, is there any limit to the scooters we can honk at once? And there is absolutely no limit. So imagine like 3 in the morning, we open the window, campus of like 75,000 people, and hundreds of these scooters are going off. And we ran it in like a burp intruder script, and we're like, okay, we got to stop it. And we turn it off, and 25 minutes later, the scooters are still, it's just going. It's definitely unintentional or ethical research. But after waking the campus up, we kind of realized, like, why don't we just like take a step back? These scooters are basically the same as cars, right? You have a SIM card plugged into the scooter, and it talks to some API, and you're able to kind of interact with the car. And after Elon Musk was like, hey, you should be able to control a car with your phone, all the other auto manufacturers started building out these like connected car APIs and all this kind of like, stuff that's similar to the scooters. So we realized that we had access to like a high-end I still don't know how you say that. But we were going to figure out like how to do this Hyundai because, through the mobile app, you can do stuff like lock it, unlock it, start it, flash the lights, do whatever. And we wanted to play around with this because we could kind of try to formulate like the same attack we had against the scooters where it's like, unauthorized access or just being able to kind of play around with it. So we looked more into this, and we realized that, first of all, the iOS app had SSL pinning, but Android did not. So very easy for us to start intercepting the traffic. So when we started actually looking at it, we realized that there are these interesting endpoints to actually authenticate to the app, right? We saw, like, immediately after we started intercepting, if you wanted to turn the car on, you would basically authenticate to your Hyundai account, and you would log in, and you get this JWT, which was basically an encrypted, it was a signed email of yourself, right? And it was interesting too to us is that you'd also pass in your email via the post request to turn the car on. And this was really interesting to us too because, the first thing we thought is like, is it doing some sort of comparison between the authorization bearer and the username in the post request? And to kind of mess with this, we fuzzed around it a lot. And we eventually realized, this error message here where you could actually send it in a GET request where you could pull your details. And again, you're passing in the email address as like a parameter. And this is unusual to me because the JWT has the email address. So it's like, why are we passing it again? So it made me start thinking about it from like a kind of deeper understanding where it's like, maybe there's kind of a second API, right? So our guess of kind of how it works is like, we pass in the email of the account we're working on, and then it parses our email to make sure that they're the same. And then after it compares it to validate, we are who we say we are, it sends it to a second server, right? We're assuming it sends it to a second server because just kind of like, why are we passing in the email a second time? Just kind of thinking about it a little bit. But we kind of start fuzzing around with it a little bit more, and we realize that we can, re-register like new drivers. So we find this endpoint to just register an account, and we realize that, very typical error message, email address is already registered. But from the context of like a second API, we're like, well, what could we append to the email address to get it to match the JWT if it's being passed to like a second server? So all you had to do is you append like a new line character at the end of the email address. And then what that does is when you resend it, you'll actually be authenticated as the victim. So for instance, here, if we go to this HTTP request, victim@gmail.com with a new line character appended matches victim@gmail.com, and it lets us basically, turn cars on. And this slide's blank for some reason. Oh, no, it's not. It's actually. But anyway, with this, the core means of authenticating the user is the email address. So if you know someone's email address and you use this vulnerability, it's very simple just to plug into their account and access their car, right? So we did like what a hacker should do, right? And build like a cool script, right? So what we did here is we did this little keyless entry script. So all you do is basically, you get the victim's email address, you plug it in, and then the second part here, which is kind of interesting, it asks you to plug in the attacker's email address. And the reason we do this is because there's actually an HTTP request to like add a second user to your account. So once you do these two things, what it'll actually let you do is just completely control their car. If it loads, we'll see. Oh, there we go. So the script retrieves their token after doing the new line trick. And then it asks you, do you want to invite yourself to the victim's account? And if you want to, you can do it. And then we have this cool control panel where you can flash the headlights, start the car, unlock the car, or update the vehicle pen. And Spectres, who's like a really, really smart car hacker, actually realized that after you do this and you authenticate to the car, you can use the same access to pair your phone to the vehicle. So for Hyundais, you can actually drive them away, right? I think there's a cool little end bit where Spectres actually breaks into the car. Let's see. Oh, here we go. Yeah. So here we've unlocked the car, and you can go ahead and see Spectres getting in the car. And imagine this is your house. I don't know. Very very exciting stuff. But yeah. So as a first kind of proof of concept for the research, we're like, okay, we've hacked Hyundai, and you can basically go up to a car. Or sorry. For this one, we're kind of thinking about it from an impact perspective, right? Where it's like, I maybe know like 4 people's email address, So when I took a cruise with or something, I have to invite them to the cruise thing. I've got their email address, and you can reasonably predict an email address, but it's not so cool in like you can't really walk around and just access anybody's car. So we thought about it from a different perspective. And we're like, well, what's like a identifier which is like known to everyone for vehicles, right? And that's kind of the VIN number. At least for a lot of cars, you can kind of walk up to it and you'll see the VIN number on the windshield, or you'll see like a VIN number in like another part of the car. Some of them are kind of hidden like behind the doors, but it's relatively easy to get. So we kind of thought about like trying to hack these from the perspective of VIN numbers, and let's see, go back into here. We're thinking about this like, okay, what's next? Like we want to be able to like hack a car via the VIN number. And if you go to a parking lot, right, like you've got all these VIN numbers, and it's on the windshield, kind of like we talked about. And we realized from the perspective of VIN numbers, like after looking into a lot more and realizing kind of this infrastructure, that SiriusXM was actually providing connected vehicle services for like tons and tons of different car manufacturers. And the way SiriusXM worked and like the core identifier for SiriusXM's connected stuff was it would use the VIN number of the car to like kind of index the car through the apps, right? A lot of different companies like Tesla and Rivian will like build like in-house stuff, but SiriusXM actually provides stuff for like, let's say like Toyota, Hyundai, you know, all these different car companies. I would say probably like 60% of car companies use SiriusXM to power like the connected vehicle stuff where you have an app that talks to, you know, the API on your car, right? So if you own SiriusXM, you own 60% of the car industry. So you kind of understand, yeah, exactly here, right? But to approach this, it's like, where do we try to hack? So the goal here is like, we have this list of car companies from like an API from SiriusXM, which is like FCA, Nissan, BlueLink, which is Toyota. And we kind of realized like we need to get access to one of these cars to start testing it. So we started decompiling these car apps without actually having access to the car. And we're just kind of investigating and looking around a little bit. And we found this URL, telematics.net, right? And from a car hacker's perspective, it's like, oh, telematics. Like that's basically describing what we want to do, right? So from a recon perspective, we start like digging into this telematics.net domain. So we parse through all these APKs for the actual connected car apps, and we pull out the same domain, telematics.net, over and over again. And we realized that, you know, it basically had this format where the core URL is mobile.telematics.net, and then you'd pass in a header for what car you're trying to access. So if you wanted to authenticate to like a Honda, you'd pass in Honda, username, password, and then you'd access your account or you could control the vehicle, right? And then we kind of looked around a little bit after authenticating, and we realized that you get an authorization bearer, and then there's this like interesting parameter, which is like honcust with an ID, /vehicles, /VIN number, /start. And then, you know, command like remote_start. Sorry, I've done a lot of coffee, so I'm like probably talking too fast, but anyway. Since we're in the actual customer account, we can kind of see like how the actual like APIs work, right? So one thing we saw in the app is like this endpoint called exchange token, which was really interesting to us because what it wanted was like a customer ID, and then it used our username and password where it exchanged it to an access token to actually execute the vehicle commands, right? And from an authorization perspective, like let's say you have the app, you log into the app, and you got that bearer token that we saw before. We're kind of curious about why this existed because it's like, it seems to only create the token for interacting with the vehicle, like starting it and unlocking it. So we're like, this is a really interesting request because if we could, you know, play around with this, or like what we could, you know, initially try to do is just pass in like a Honda customer ID that's not our own. It would return like 401 unauthorized, right? And after looking at these apps for a long time, we realized that the actual like, I wouldn't call it a URI, but like the format of, you know, the identifier where it has honcust and then the :ID, it matched the same identifier that they use for VIN numbers, right? Yeah, anyway, so we thought about it for a while and we realized it matched the format for kind of like VIN numbers we saw before. So even though we couldn't pass in like a Honda customer ID, we could actually pass in like a specific VIN number. And what it would do is just generate an auth token. Even though it was failing for the honcust one, we would pass in instead a VIN number and it would just give us an access token. And this worked for all VIN numbers, for all customers. So Honda, Nissan, Infiniti, like you could basically just plug in the VIN number and then you get the access token and you can just unlock, start the car. And it was just a really, really interesting finding. It's like, you know, all these different cars, like millions and millions of vehicles are like connected through this one API. And it's like this really big like dependency issue where it's like fundamentally from a security perspective, like this one post request is able to unlock like, you know, 60% of vehicles. It's like pretty crazy to me. It's like that should be changed. I don't know, like we'll see, yeah. But anyway, if you were to go to a Whole Foods parking lot, you know, cars, it's maybe more modern cars, right? You've got access to about like 60% of vehicles, but for the other 40%, it's a sad face, right? So we really got to keep going. And what we realize is like, there's all these different apps, right? Like for instance, like LoJack, you probably heard of, and like Gold Star, like dealers use. So for instance, if you go to a dealer now, a lot of dealers, what they'll do is they'll have like this device installed in the vehicle where like, let's say you're not making payments or whatever, they'll be able to track the vehicle and shut off the starter, right? And this is like really, really interesting to us because it's like, oh, this device is like hooked up to the core of the car, right? And it probably hits some API, right? So all these companies are powered by Spirion, right? Spirion's like this big parent company for all these different apps for fleet management, consumer devices where like a consumer who wants to like mod their GTR or whatever can like plug their thing in, right? And so we're like, well, we got to own Spirion. And to own Spirion is very simple. You go to admin.spirion.com and you type in a asterisk and a pound symbol, and it's just SQL injection to authenticate as any user, right? It's like, it is 2023. I'm a little worried myself. But now that you're authenticated to admin.spirion.com, you have access to send arbitrary like CAN bus commands to like 3 million vehicles, right? And Spirion powers, this is an example one, this is like a semi-truck, right? So you can see like inner sleep, motion detected, ignition off, movement. This is just like a logging portal for it, right? So you can like, just to see like the level of access, but there's another part too where it's a device configuration script. So through this API, the administrators can plug in a serial number and update the device configuration, right? So Spirion's capabilities are really, really fun because it can basically like turn off the starter in most things. And so imagine this, right? This is our fun attack scenario. You basically just pull all serial numbers, you disable the starter, and then you update the device configuration to just null it. And then that's like, hundreds of thousands, if not like 1 million vehicles that just have their starter disabled, and then also you can't fix it via Spirion. So it's just like, all right, like that's a lot of man hours from like a from that perspective. The second step to owning Spirion is another simple one. We found this other site, backend.us.spirion.com, which is the actual thing that powers admin.spirion.com. And we tried to go to the admin panel on this thing by hitting /admin, and it's like, no, you can't do that. And we're like, okay, what about uppercase admin? It's like, all right, that's cool. And then we did the same thing for console, where console had this really cool thing where you could, I don't actually have a photo, or maybe I do, let me see. You can basically just run console commands via this nice little list console UI that they had. And then we just throw in our reverse shell, and now we have root on the core Spirion backend API, right? So in case there's any issue with like, maybe the admin UI has like a stop, you can't do that. It's like, all right, we just like rooted the thing that powers it. Like, what can we do here? So here you can actually, the actual core backend.us.spirion.com/admin is basically just this big UI for updating user accounts, updating vehicles, and viewing all vehicles, right? So you could do a query for like, let's say Altima or like Nissan Altima, and it return the serial numbers, the IMEIs, and the device IDs for all these connected devices. So, each Spirion device has like a SIM card plugged in, right? So you're able to talk to these remotely, at least for like, the ones that are active. So you can see like 2023 Ford Transit, Hyundai Venue, just tons of random vehicles, right? And there's also stuff like this. And you can actually talk to these devices, UDP, SMS, Twilio, iOS push, and and with those you can actually like run arbitrary can commands and stuff like a cat. Like the limitation here is like figuring out how to actually talk to it. Like I didn't want to spend like 50 hours like digging through a cat like manual. I don't think Spirion wanted me to either, but it would be a fun project to dig a hole in someone's backyard. The next thing you can do here is like, since Spirion runs fleet locate, where, like let's say you run like some fleet of vehicles, like let's say a police service or an ambulance service, we can update it using that backend.us.spirion.com, just invite ourselves to a state police where we can track and manage the police fleet. And there's fun stuff you can do here, right? So for a proof of concept to demonstrate our access, we've invited ourselves, and you can track the vehicles. And there's actually a fun thing that I don't have in the photo, but you can actually send the police cars like locations. So I guess like if you're a 911 operator, you could like get forward a police vehicle like a location, right? Anyway, so full Spirion summary. Yeah, there's that fun scenario where it's like, what if somebody does this? It's kind of fun. It's over 3.5 million vehicles, and I'm granted like it's always hard to find like the actual number, right? Like if you ask a company like, hey, I want to disclose this, like, can you tell me the actual impact? They're like, you can just estimate it, right? But that number was in the system, but I assume like probably like 60% of that is actual like active vehicles, right? So cool, we've hacked Spirion, and it's time to go back to car companies, right? We'll do a speed run really quick for hacking Mercedes-Benz, right? Mercedes-Benz, super hard in scope. I mean, like, we tried to hack the core apps. Like, we tried to find OWASP top 10, fuzzing, do all this stuff. We tried to hack, like, the core vehicle registration portal. Didn't get anywhere, right? And we're just, like, scratching our heads because, like, we really want to hack Mercedes-Benz. We have a German guy in the chat who's giving us crap for not being able to hack. We're like, all right, like, what do we do? So Chubbs, being the recon man he is, pulls this subdomain, right? It's a pretty simple subdomain, but it's like umas.mercedes-benz.com, and it's for like contractors to register to Mercedes-Benz. But it actually plugs into their core SSO. So after we register, we're plugged into their core SSO, and we can basically just pull up any core SSO app, right? So instead of having to do like workarounds and trickery, we just go to their Mattermost, or basically Slack for Mercedes-Benz, and we're just authenticated, and we can join, Azure Cloud, Cloud Security. It is their active Mattermost, right? And this left app is basically for querying cars, right? So we can search, like whether or not a vehicle is active, like digital fueling, geofencing, and we can basically like query stuff and do kind of the same stuff we could before, where you can assign a new owner of the account or inviting it via email. And then you have Mercedes-Benz hacked, right? Okay, so Mercedes-Benz, we own them. We have SSO access to all their core production apps, right? The next step is like Ferrari. And Ferrari, as expensive as the cars are, they don't actually have SIM cards, right? So Ferrari, it's kind of tricky because like we just want to pull like user info, right? If you pull user info for Ferrari users, it's like the worst you could do basically from a web perspective for Ferrari. And we found this staging domain, which was cms-new.ferrari.com. And within the JavaScript, there is a reference via API key and API URL, which is like their core API, right? And funny enough, you just plug that API in, and you get access to everybody's user information. You can't really see the endpoint, but it's core API v1 users. You query it, and it gives you email, phone number, full name, address, all that stuff, right? And funny enough, like 2 or 3 months after we disclosed this to them and they fixed it, Ferrari actually got hit by a ransomware attack, which exposed like the same information, right? And I'm not saying any parallels. I can't get any information from this, but like we were kind of worried that like the fix was implemented correctly or something, and like someone abused this after we like shared the blog post, but can't really tell. Haven't heard any info about it. Anyway, this is a good photo that a good friend Nathaniel Latmer shared one time, and it's how do you feel about bugs? I guess it's like a kid's drawing book, and the person's just like, it's a funny photo. They just don't look very content, right? We've done like a lot of like cool research before where it's like, like really deep technical stuff where it's like finding new attack methodologies, right? And I was kind of bummed because like with the auto industry, with these different companies, it kept feeling like we're hacking the same system over and over again via like more like trivial or novel stuff, right? So like at this point I was kind of bummed is like we should try to do like something technical, right? But alas, we continue on and we realize BMW, we'll try to hack BMW next, right? And for BMW, there's this SSO portal, kind of the same thing similar thing to Mercedes-Benz, except it's like a self-service gateway for their employees, right? And we find this portal and we fuzz it a little bit, and eventually we find this application.waddle file. And curious enough we are for this core API for their SSO management, we look at their waddle file and we realize that if we go back a little bit, I don't know why it's not listed, but the waddle file basically had this endpoint, which is REST API chains accounts, unique account ID, TOTP. And what it did is if you plugged in an account ID, you could get the one-time password for that user. Yeah, so and another thing too that I think we didn't document was it was an LDAP query, right? So if I plugged in a user account to try to look up a user, you'd think you have to like maybe brute force like Sam dot and then brute force last names to find a user account. But what you could actually do is just type in like Sam asterisk, and the LDAP query would autocomplete that user account, right? So now we can just fuzz through all the users, reset every account, do whatever we want, and that allows us to access core dealer portals for BMW and Mercedes, or BMW and I always forget the other company, Rolls-Royce, right? So if you bought a Rolls Royce, your information is in this system, and as a dealer, I can put your VIN number in and basically grant myself access to your car, right? And for the core BMW, that basically means like you can do the same thing. Track, unlock, start for BMW cars, right? And I can access these sales documents too, so if I want a price quote, I can see what they kind of charge for whatever. But alas, we carry on, right? At this point, we've hacked a lot of these different car companies, and I've tried to hack. I've done like a little bit of hacking on like Tesla and Rivian and these like more modern, modern like car companies. And we're thinking like, okay, we want to hack like Tesla and Rivian, but like there's got to be an easier way than actually going through the Tesla app or the Rivian app, right? And we think about it from the infrastructure perspective, and we're like, okay, a company like SiriusXM, uses a satellite or whatever, like the same thing a phone company would do to talk to the vehicle, right? And we're thinking about it, and we're like, okay, so who actually provides like the SIM cards and the SIM card, telecommunications part of the car companies? Because if I'm BMW in, let's say, like 2011 or whatever, and I'm like, damn, like I really want to have someone control it from their phone, and I'm like, are you really going to hire an in-house team of experts who understands like this protocol to do that, or are you going to go like contract it from someone else? And it turns out there's a lot of like dependencies that exist, right? So for instance, like Tesla and Rivian use providers like AT&T, Verizon, and these big like cellular companies that provide like normal SIM card stuff, right? And we started Googling it a little bit, and we realized that in this one article from 2014, Tesla basically said that they had a deal with a company called Jasper Wireless, right? And what Jasper Wireless did was provide connectivity for Tesla's like in-car infotainment system. And we're like, well, what is this Jasper Wireless? So we started looking at it a little bit more, and we realized it was acquired by Cisco. And it basically provides a system for like managing every telecoms. And I'm not joking about that. Like this system, Jasper Wireless, like it's basically a UI and an API where you can treat these SIM cards as like REST objects, right? So if you go to like, if you're AT&T, you have all of your SIM cards here, and you can click a SIM card, you can deactivate it, you can send SMS messages, you can read SMS messages. It's like a God mode portal for SIM card management. And this is the photo. Jasper Wireless legitimately provides service for all these companies. And like what bigger single point of failure than trying to hack Jasper Wireless, right? So we look at it a little bit more, right? And we realize that there's all these different subdomains, right? And from the article from a long time ago, and like checking, if you're in a Tesla and you open up the web browser, you can Google it and see what your IP address is, right? And most of them will turn back to AT&T, right? So we assume that Tesla uses like AT&T plus Jasper Wireless. So Jasper Wireless would be, for instance, the managing system, and all the SIM cards that are plugged into Jasper Wireless would be AT&T, right? So we assume AT&T Jasper Wireless is probably what Tesla runs on. So we look at this web portal, which is public, that has like a username, password, login, and we're sitting there trying to figure out like how to hack it. And after like a really long time, we're unable to break through it from an external perspective, right? And eventually we get an account for like bell.jasperwireless.com, and we find this kind of boring vulnerability, which is like XXE post auth. Shout out to Corbin Leo for his tool for out of bounds XXE exploitation. Sadly, though, you can only read like one line from a file at a time, and you have to be authenticated. So we're like kind of like bummed because it's like, well, we really can't own Tesla with this. So we kind of take a step back and we're like, well, if I'm AT&T, like how do I provide business solutions to customers like Tesla? And there's actually this website, marketplace.att.com. So if I'm Tesla and I want to buy a SIM card from AT&T, or I want to buy like 100,000 SIM cards from AT&T, I go through this portal, right? And through this portal, you buy a SIM card, they provision it, and they mail it to you. And I actually did this. I got my little SIM card in the mail. And I was able to access this like API, right? And we probably spent 3 or 4 weeks trying to hack Jasper Wireless, the core web app, didn't get anywhere. And then we took a step back and switched to this. And after probably 3 hours of testing, messing with it a little bit, we got an error message. And within the error message, it's a XML request that's being sent to att.jasperwireless.com. And it's like, you have this error. I'm going to dump back to you the password and license key for Jasper. And we're like, yeah, at this point, it's like, okay, time to start reading that Jasper documentation. So we plug in the API key into Jasper, and it's really hard to read, actually. Anyway, this is the XML API for Jasper, and we're using the password and license key for AT&T, and it's giving us data back. And after a few hours of like hitting around the API, we basically pull, we query using like a few different like built-in XML like SOAP API stuff, and we're able to basically retrieve the Tesla's Jasper data, right? So if you see here in the response, it's so hard to read, I'm sorry. I should have done a better job here. But the process for this is basically, one, you enumerate through all the companies under AT&T. So Tesla is a customer of AT&T, which is processed through Jasper Wireless. So to enumerate that, you basically take ID 1, you pass it through this SOAP API, and it would basically return the name of the company, right? So to enumerate through all the companies in this, you send like 50 different IDs, and you get 50 different things back. So we automated this with a script, and we were able to retrieve a list of all the companies. And then we index it to Tesla, and you query Tesla as a company. You can see they're spending like millions of dollars a month on SIM card stuff, and you're able to retrieve the list of SIM cards associated with Tesla. And what you could do from this API is basically just hit a button and then disable a Tesla's like internet, right? So like you can get all the data like relatively easy as well. So it's like actually a realistic attack. So when we reported this, we reported it to AT&T, but we didn't hear anything back for a few days. So we reported it to Tesla, and Tesla immediately was like, "We got you." And then they blew up Jasper, I guess, or like got their attention, and Tesla rewarded like a $6,500 bounty, even though it wasn't their like problem initially, which was super cool. But Jasper fixed the issue in a couple days, or AT&T fixed the issue in a couple days, where they redacted and rotated their API key. So kind of post-mortem, right? This affected over like 100 million different SIM cards for just specifically AT&T, right? And what you could do is you could send SMS messages, like using any of the affected things. So 100 million SIM cards, you can send and read SMS messages. We saw like a lot of like customers that were AT&T business customers that were not allowed to share, but like a lot of really, really, really like juicy customers of AT&T where you could, and they may not be cars, they may be like business phones and whatnot. For a lot of them, you could just geolocate the SIM cards, right? So if you're, a customer, you can just query the location or whatever. And the last thing you can do is just disable, right? So for Tesla, it's just like you replay it over and over, and it's just like you've disabled all Tesla's internet, and they got to figure out what's going on. But this is just one that's just so crazy to me, because it's like that photo from before, that map, right? That is one web app, or like one source, right? Cisco has this source somewhere on their system, which is like, hey, this web app we deployed at these like 10 hosts, yeah, that powers the world. Like, if you take these over, you could just like, do whatever, right? Like you're able to do like whatever to these SIM cards, but yeah, lots of different car companies affected at this point. But to review, yeah, we spent probably 3 or 4 months on this, and there's like a lot of things I could definitely continue talking about. So for instance, this left one, I forget what car company it was, but you can just query the camera of the car for any car using the VIN number, right? So at any time, you can geolocate it, activate the camera, and look out of it. And on the right one, we actually hacked like California's digital license plate, which is Reviver, right? So for Reviver, you could authenticate it as like a super admin and like track the license plate or update the license plate to say like stolen or something, right? But it's super fun, right? But to review, this was like a big collaborative effort by all these people who are really, really, really awesome. And like overall, it was like Kia, Honda, Infiniti, Nissan, yeah, all these companies, right? Like where either it was being able to access the car via email address, being able to access the car via VIN number, or just like full organizational ownage, which leads to the same things, right? So like overall, like it's kind of worrying to me, because like there's a lot of the car security I see is really, 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 really cool, like car hacking research where you're in the car, you're in the CAN bus, you're doing like a physical attack, right? Or you're attacking like the Wi-Fi network, which is protected by the car. But like there's been a solid amount of research into like hacking the APIs which power the car, but I feel like there hasn't been enough, right? Like all of these systems, like each of these car companies probably had like 1 or 2 spots where you plug the VIN number in, and it'll give you like some metadata about the user. For instance, like miles driven, first, last name, etc. Right? So it still feels like all these infrastructures are still just like very, like if you put in the same amount of time, I bet you could find the same vulnerabilities. So I'm really hoping that we kind of progress a little bit more. But yeah, thank you so much for coming to the talk. Super appreciate it. Well, I could buy maybe like one of those electric scooters. I think all in all between us, it's like $9,000 or $10,000 totals in bounties. One of the reasons I was a full-time bug bounty hunter for like 5 years, and in that time I was like grinding, like focusing on money. So this was kind of like a foray into like, let's just hack these companies that don't offer bounties, because like even though it's free work, yada yada yada, like we just thought it'd be fun to own these things and maybe help encourage and like build that dialogue with them. But yeah, not too much. But yeah.
Are they success with them, or are they all who they actually lined up on down, or is it stuff out there that sounds but haven't died to them about closure?
Oh yeah. So for like. So you're referring to like getting in contact with these different companies?
I mean, I know if they're happening, what
No, yeah, 100%. Oh yeah, no, 100%. Yeah, so he's basically saying like the car companies that weren't included on the list, were we able to get in like contact and report vulnerabilities to them, and whether or not they were like okay. Yeah, 100%. There were a few affected car companies that aren't included on the list where we basically just like didn't ever have time to do it. For instance, like Subaru was the one we wanted to hack, but like didn't actually end up looking at it. But yeah, basically we weren't going for like a total all car companies. It was basically just like a big percentage. So yeah, I haven't actually checked a few of those, but yeah, thank you. Oh yeah, 100%. I think like one of the issues we had with GM was like getting initial access. I was trying to find someone we know who owned a GM who like wanted to let us like test their car, but it was like kind of difficult. But yeah, it'd be definitely fun to like look into. But yeah, 100%. Yep. Yeah. So for the reaction we reported them, most of these companies were actually like very responsive. They responded within like 48 hours max. There was maybe like, I think Spirion was the longest, where it took them like 4 or 5 days. But it was pretty positive. One thing Shabam Shah like kind of showed me to do is like including the kind of like Google standard disclosure thing at the very front of the vulnerability disclosure, where it's like, hey, security at honda.com. We intend to disclose this vulnerability in 90 days, but we're reporting it here, and through your like kind of like vulnerability disclosure program. And they're all very receptive, but like none of them were really like super like, oh, we'll pay you a bounty, we really want to pay you or whatever. So yeah. But yeah. Yeah, so like a lot of them, most of them have like a security at, but some of them have like a, mt-prod-security disclosure at, and you kind of have to ask around a bit. Luckily enough, like the network of people here had like good enough connections. Like for instance, I said Mike Roberts actually in Germany, so like we kind of had to ask around a little bit there to get the actual email. But once we had it, it was smooth sailing. A few of them like didn't have an immediate way to get in contact. I wish there was like if you're familiar with security.txt, it's a project by Ed Overflow and a couple people where it's RFC for including like a security.txt endpoint, kind of like a robots.txt, where it has an email address to get in contact with. I didn't feel like any of them were like at that point where they like really advertised it, but you could find it relatively easy. Yeah, 100%. To talk about it a little bit more, like the homogeneousness of it, of like, for instance, like Jasper Wireless and Spirion, where like these big centralized players. I think the reason that exists kind of is because like, if I'm an IT contractor who has a service like, let's say, telematics, right? I really want to sell it to all these different car companies, and I think that's kind of like, the way enterprise sales work, I think ends up to a point where it becomes like this very centralized thing because, there aren't too many players in the game, and also like everybody's kind of like working on very similar things. So if I have a solution which works perfect for Ford, I could probably like mess with it a little bit and then make it work perfect with Subaru, and then you end up with the same player in the same space, right? And especially with like Jasper Wireless is like, it's one of those things where it's like a very specialized solution that is like does a lot of heavy lifting, right? Like, to query that many like physical devices, like to open that dashboard and it's like, oh, there's 200,000 SIM cards that I maintain the physical address of, is like an absurd like workload, I feel like, to the point where it becomes kind of homogenous because it's just so specialized, right? So I think Cisco made a good decision buying that product, and they're going to have that locked down for a while. But yeah, it does feel like overall it's very homogenous. And same thing with like, to kind of comment a little bit more, you see like the same like deployment issues, like for instance, actuators. I think like Porsche had like a disclosed actuator on their production API for vehicle access. So you could just like do a heap dump, get an access token, and then go like track some random person's Porsche or whatever, or just call the API to like unlock it or do whatever. And that was the same thing for all the car companies, where it's just actuators everywhere and like common authorization like vulnerabilities. Yeah. I think like, careful as in like, are we kind of like a little reckless or like? Oh, 100%. Yeah, that's one of the benefits of like, I used to joke with people like a really long time ago that I would never make a good like illegal hacker or black hat hacker because like I would just get caught immediately. Um, they definitely knew what we were doing, and they definitely noticed us. A few people like reached out. I think Tesla emailed actually because they recognized like the user info we sent over, and they emailed us like, "Hey, what you doing?" Like, so like no, they like, from an attack scenario perspective, like being how loud we were, we would have like had 3 days maybe of like maintained access, right? Like it would have just been eliminated. But yeah, thank you for the question. Yeah, 100%. So with SSL pinning, it's kind of always been like a interesting thing with like bug bounty hunters, because like what SSL pinning does is like, if you're trying to decompile an app and like intercept the HTTP traffic, you kind of, it adds like a few extra steps where you need to use a tool like Frida, and Frida basically like injects in between like the actual like runtime of the app. And when you're doing that, you can basically like intercept it, disable SSL pinning, and continue. But like, I wouldn't say, from a security perspective, SSL pinning is like a good solution and like adding extra man hours or whatever to like preventing hackers. But I feel like one of the reasons like SSL pinning is so big is for people like spammers, right? Like if I want to spam, like whatever on Snapchat, I'll have to reverse Snapchat and get the APIs. And then I can, call APIs directly to like, it's like, yo, you want to buy Ray-Bans, But I think the reason that they SSL pin those is like prevent people from like doing spammy stuff and like, building these unauthorized apps and whatnot. But yeah, I think it adds maybe 3 or 4 days of like extra work at max to like a sophisticated attacker. But most people have workflows to bypass SSL pinning. Yeah, 100%. So it's a really good question, actually. I think like Subaru was really tough. Tesla's super locked down from like actual AppSec perspective. It's hard to say too a lot of times. Like for instance, like we weren't able to like actually hack Rivian, but like Rivian will have like an environment that pops up every 6 months where it's like, oh, here's our production GraphQL that you can do like whatever on, and then like take it down like 2 days later. So I think if you're persistent enough, you could probably like pop the more hardened ones. But yeah, there were a few that were tough, like Subaru, Tesla, Rivian, Toyota. Yeah, so Toyota was interesting because we thought we owned Toyota because Blue Link through SiriusXM is Toyota, right? So we thought like, oh damn, we own Toyota because it's through SiriusXM. We never bothered to confirm it because we just assumed like list of car companies. But in like 2016, Toyota actually disconnected from SiriusXM and like do their own thing now. So we didn't actually get around to looking at Toyota, which is really sad. Oh yeah, that's another thing. Even if the subscription wasn't active, we were still able to call the API. And it's really kind of spooky because it's like, I don't know, I think there's like a lot of like law enforcement integrations or like vehicle tracking stuff for these like APIs and what they provide access to. There's a funny tweet from a journalist a long time ago where it was like a drug dealer, like a guy selling coke out of his car, right? And in the court document, they're like, here's everything we use to track this drug dealer. It's like vehicle access, phone access, like this crazy, like this list of like 8 or 9 things that just plugged into because he had an SUV and they tracked it, via cell stuff. So I feel like realistically, like you'll always be able to access it if the SIM card's active. $1940. No. Yeah, I think honestly 2012 before. But like realistically you can disable it if you're like really wanting to. Take a screwdriver and hit it a bunch until it turns off. Yeah, I don't know. There's probably a year that works. Yeah, thank you guys again. I really, really appreciate everybody coming to this.